Now we're going to start to talk about percentiles. And you guys, z-scores and percentiles go hand in hand because you use your z-score to find your percentile. Your percentile is at or below that number. Oh, the first letter is E. Yeah, no, that picture was wrong. Totally wrong. Are you done? You're checking, okay. So you guys, when you were little, or have you ever been around people that have been talking about maybe their babies and they're like, oh, they're at the 50th percentile, they're 99th percentile, or have you ever gotten a test score back and you're like at the 81st percentile? So what that means is that if someone is at the 81st percentile, then they scored as well as 81% of the students tested. Percentile always goes from the bottom to up. You never go from the top down. It's always from the bottom up. So 81%. So there's 81% of people below you, basically, okay? Okay, now, I have to draw this picture with you. Okay, I'm just going to let you guys draw it. How's that sound? Can you guys see it okay? Do I need to zoom in more? Okay. This is what we call the empirical rule. It used to be, this is how professors graded. So I'm going to tell you, we're going to let this sink in. You guys at home, I'm going to pause it. You do this. So between the first standard deviation right here, 68% of the data lies. So 68%, so empirical rule states that 68% of all observations fall within one standard deviation of the mean. It's the mean minus one standard deviation, the mean plus one standard deviation. And we'll talk about how you get those numbers. Within two standard deviations, 95% of the data falls. And lastly, I shouldn't be using green because I already did. (99.7%). And I think you guys did this in AP psychology as well, correct? Okay, so here's an interesting tidbit so you guys know. College professors used to say that the majority of the people, because this is a bell curve, right? So 68% of the students would get C's. Okay? So they would grade on a bell curve. And there's still professors that do this. 68% of these students get C's. This is your B range. This is your A range. Do you guys see? Or this would be your A range. This is your A plus. Do you see how different the area is underneath it? You guys see that? So there are professors that would say, okay, this many people get C's, this many people get B's, this many people get A's, this many people get D's, this many people get F's. And they would convert everything to a Z-score, and they would see where you would fall. And if you fell in that range, you got an F. And that's how curves start too. This is how curves start on a test. So the empirical rule really, like it, professors used to do that. I don't know that that any professors do that, but there are still some that do that. That they are like, yep, I grade on a curve. And it really stinks because now there are some people that are like, ooh, I can't wait for them to grade on a curve because there are some people that have gotten really bad grades and they're like, ooh, I got an A. I want to say in organic chemistry, that was one of the things. So, okay. So that's the empirical rule. I love the empirical rule. We're going to do a lot with the empirical rule. So but we're going to get back to that. So this is just a density curve. This is one form of a density curve. The normal curve is a density curve. But there are other, you guys, not all density curves are normal. There are skewed density curves. There are density curves that are boxes. The biggest density curve we deal with is the normal one. And it's always approximately symmetric. So the biggest thing you need to know is that all density curves have an area of 1. So underneath their shape is an area of 1, no matter what shape it is. If it's skewed, if it's a box, if it looks a normal, the area is 1. So you have to keep in your mind that all of these little areas are going to add up to 1. And I am going to give you this little bit of information. I don't know where I'm at. Oh, we're good. That's what we're going to do next. Okay, I did this part. Good. Do this. Let's make this. Okay. That needs to be later. So if you see an N, that means it's a normal distribution. That will change. There's a couple of distributions that we're going to talk about this year. This is the first one. So if you see an N and then 2 numbers, you know, oh, that's a normal distribution. That means it's going to follow that empirical rule, okay, that empirical graph picture. And then the first number you see is always your mean. The second number you see is always your population standard deviation. So right now, everything we're doing is right now is population. What we did in chapter 1 was all sample. This is all population now. And this will actually come back later down the road in 3rd quarter, okay? Okay, Do you like how I just started it? They don't know what I'm talking about. Ha ha ha. Okay, so this is your most basic of basic normal distributions. This means it's a normal distribution with a mean of 0 and a standard deviation of 1. Basically, what this is your standard deviations are your z-scores. Does that make sense? Because your mean is 0. So we're going to draw some normal curves. Okay, so let's talk a little bit about what normal curves are. I know you know what normal curves are, but let's talk about how standard deviation affects the shape of the curve. If it's tall, you got really tall ones, and then you got really wide ones like this. This is actually going to have a small standard deviation. This will be your large standard deviation. You should probably draw your normal curves to match your standard deviations. So you guys, a large standard deviation, of course, is that one that we did at 195. That is a large standard deviation. It's going to look like this. Your normal curve would almost look flat, right? It looked like a little mound. A small one is a fairly small standard deviation. It should probably be tall and thin. I just need you to know, I draw all my curves for you guys large, because I want to show you the area. I want to so you guys get a grasp of what the area looks like. But they should probably be somewhere in between these two. So we're going to start with one of our normal curves. I'm going to kind of make it mound shaped and flat instead of tall and thin. We're going to put the mean in the middle. The mean always goes in the center. Okay, so you guys, this is the mean. 50% of the data falls below the mean. 50% of the data falls above the mean. And then we're going to put in our standard deviations. Notice that I don't do very good they should be all equal parts, okay? Are you going to lose points for this? No, but you want to do the best you can. So remember on the empirical rule, it was the mean plus 1 standard deviation. Well, 0 plus 1 is 1. 0 plus 2 is 2. 0 plus, it's 0 plus 2 times 1. 0 plus 3 times 1. And then over here. Because our mean is 0, our standard deviations are the actual z-score. So we're going to talk a little bit about area because I want to show you. So at 0, we'll do a basic one. We'll do the most basic one, okay? How much data lies below 0? We just talked about this. This is 50. This is 50. You guys, your areas, you guys are really tired today. I understand. Listen, I get it. It's Tuesday. I don't know, there's something about Tuesday, right? Tuesday is, I'm always tired. So, you guys, 50% of our data falls below 0, 50% of our data falls above 0, and the two areas should always equal 1. Always. Whatever area you're dealing with, even if you're dealing with 3 areas, they should always equal 1. So let's draw another one. You're going to get really sick of drawing these, but I love them, so we're going to draw lots of them. And every time, so this is a given, no matter that I love them or not, this is a given. If you are doing a normal distribution problem, there should always be a picture. There should be a picture that matches your work. We're going to put 0 in the middle again. 1, 2, 3. 1, 2, 3. And you're going to label it just like we did the other one. Okay. we're going to talk about one standard deviation. Okay. So we're going to talk about what's in between the one standard deviation and what's in the tails. These are called the tails. So we have an upper tail and we have a lower tail, and then we have what's in between. So we just learned that the empirical rule said that in between one standard deviation, this is 68% of the data. So 68% of the data lies within one standard deviation. This is 16%, and this is 16% because the tails are always equal. Okay, so what I did is I did 1 minus 0.68 or 100 minus 68, and then I divided it in 2.